So to wrap up now, coordinate systems, there's been quite a lot of technical detail, and as I have mentioned more than once, the computer is going to do a lot of the work for you. It has the parameters needed, it has the methods needed to do these transformations from one coordinate system to another, as long as it knows where it's starting from and where it's going to. So you need to inform it of that so that it can do the right thing. The where you're starting from should be baked in. When you read in your data, you should have already told it this file, the coordinates in this file are in SBG051 or they're in RT 92.5 degrees west. And then when you're working with ARC, it says ArcMap here, but this is also true of ArcGIS. You will need to tell it. You will need to say, I want to reproject. It's called project, even though it is it's more than just projection. You can do the datum shift as well. But you say, I want to go from one to another. You have to do this. You can't just go into the metadata and say, now I am in a different coordinate system, because you won't be. It will be wrong. So you have to make this transformation. And that's really all you need to remember, is to just tell the computer to do this shift. And if you're using a different GIS, such as QGIS, we recommend, there's not even a project or transform tool. You can actually find such a tool, but the easiest way of doing this is to just save the file. And when saving it, it will ask you, which coordinate system do you want? And it will sort out the transformation for you. If you don't change it, it'll just keep it in the same coordinate system. So it has to be done, it has to be specified, but it's just easy enough to do. So just remember, you start from one coordinate system and you transform your data into another coordinate system, and it's a mathematical process. It's not simply a matter of saying, now I'm in a different coordinate system. It actually has to go through this mathematical process. So this is relevant, this is true even within the SBG051 suite. So just as a quick example here, we can see we've got various points and they're all in SBG051, but the coordinates here are in TM and the ones underneath are in this 12. The central meridian is at 12. And we can see that they differ. It's the same location in these 4 instances, but the coordinates in the 2 different systems vary. From there to there, we can see a big difference. And actually, we can see where the greatest change occurs. It's in this first coordinate. Because we're moving, this is referring to our Eastings. And this is what's going to change most of all when we're moving, when we're shifting our central meridian around. So, in summation, or if you're going into a new coordinate system, transform. So some last points to make here that you need to be aware of. This is going to turn up very, very occasionally for most of you. Some of you might see this quite often, but I think in most cases it's going to be a very occasional thing. Now in GIS, we have X going along the bottom from west to east. So we start off with 0 on our left, we go to the right, to the east, and we get increasing X. And the Y goes from south to north. And we can generally call these Eastings and Northings. In Swedish, it's still the same word for some reason, Eastings and Northings, even in Swedish. Here we come to a problem though. In Sweden, in SBG051 TM and other coordinate systems within the SBG051 suite, and in RT90, the one going along the bottom, the Eastings, is the Y, and the one going up is the X. That is not a problem, generally speaking, because the GIS programs and everything, all the software you're going to use is not affected by this. It knows this. And knows it. The way the data is stored means that this isn't even an issue for the software. So you don't really need to worry about this. When might it come in? Well, if you receive data, if you receive some information, a few points of data about something on a piece of paper, someone's written them down, and they've written them down as X and Y, or it's on a PDF. You've got a PDF in and it's just a list, of written text, and they've called it X and Y, and it's in SWIRF 99TM. If they've written X and Y, SWIRF 99TM, it's quite likely that they're referring to the y-axis as being the Eastings rather than the x-axis as being the Eastings. It's not necessarily so. It may be that the person who's written this list isn't aware of this issue, or thinks that you're not aware of this issue and has done the switch for you, or what have you. So you just need to be a little bit aware when manually entering coordinates. Is this correct? So for this reason, I would say whenever you write coordinates down, refer to them as Eastings and Northings rather than X and Y, because you will avoid this confusion. But as I said, when using software, when you're using your GIS, this is not going to be an issue. It's only really going to be an issue when you go from written text, putting that into the computer in some way. Then it might occur. And what will end up is that you'll see if things look flipped upside down, then you know something's gone wrong. Otherwise, you're not going to discover this error. It's just not going to be relevant for you. So, in summation, longitude and latitude, these are angles around this ellipsoid, the ball-shaped thing. So if you see angles, that's longitude and latitude, not very convenient. When we have our projected coordinate systems, it's like distances in meters on a plane. And this is what's called, when you're creating a map in ArcGIS, ArcMap, this is what they call a measured grid. So when you want to get your coordinates around the edge of the map, you're looking for a measured grid, and then you'll get that. Coordinates must be transformed. This mathematical process. Just let the computer do it. It's not harder than telling the computer to do it, but you have to do that if you want to go from one coordinate system to another. And then the thing to remember as well, of course, from the beginning is whichever projection you choose, if you're not using just one of the standard projections from SWIRF 99, if you're working with other data somewhere else on the globe or doing something else, make sure you're using a projection that does the job properly, that is correct for the task in hand, not one that's going to introduce a whole lot of unnecessary errors. And remember, equal areas is quite often important for visualizing or for calculating data that is reliant on density of the data within an area.